In this second video for section 4.2, constant percentage change, you're going to learn about percentage decay rates and how they compare to decay factors. Decay factors are something that you should remember from the previous section when you learned about exponential decay. We'll learn about percentage decay rates through an example. Suppose you made a bad investment in a stock that is losing 10% of its value per year. Let's work through the math of what happens over that year. You start with 100% of your original investment, and then you decrease it, you subtract off 10% of the original investment. So at the end of the year, after you've done the subtraction, 100% minus 10%, you end up with 90% of your original investment. So what this means is that we must multiply the original investment by 0.90 to get the value of the stock after 1 year. So to get this multiplication factor, I converted this percent to a decimal. Let's summarize. For a quantity with a discrete percentage decrease, otherwise known as decay, as a decimal r, so we've already converted to decimal, the decay factor is 1 minus r. So comparing this to the original problem, the example that we just finished, we had a percentage decrease of 10%, and my multiplication factor is 0.90. And 0.90 is 1 minus 0.10, or 100% minus 10%. So this is an important formula. The decay factor is 1 minus r. You'll need that on your homework. Let's continue with the example and work out a formula. Suppose you invested $3,250 in the stock that is decreasing in value at 10% per year. This is going to be an exponential decay function, and you should remember what these look like from the previous section. The current value, that's our function, is equal to the initial investment times the decay factor, and then we put the number of years in the exponent. So this is the number of decay factors that we're multiplying by. Now plug in your initial investment and your decay factor, the 0.90, to get this formula. A is equal to 3,250 times 0.90 to the t power. Let's figure out how much our stock is worth after 10 years. We'll plug 10 into the function, and I've used functional notation here, a of 10, and that's going to be equal to 3,250 times 0.90 to the 10 power. So we've put 10 in the exponent. Plug this into your calculator, and you'll see that after 10 years, your stock investment is only going to be worth $1,133.20, and this is rounded to the nearest cent again.